One is the size, and the other factor is nuclear charge. Nuclear charge. Nuclear charge also increases. The nuclear charge also increases as you're moving down. So, this electron affinity should increase, but it doesn't happen so. Why it doesn't happen so? Because the atomic size overrules or overwhelms or dominates over the nuclear charge. The atomic size dominates over the nuclear charge. Although nuclear charge is increasing, and which means that electron affinity should increase, but the effect of the atomic size is more prominent, it dominates and it rules. So atomic size increases and electron affinity decreases. Overall, electron affinity decreases. Down a group, electron affinity. So overall, electron affinity decreases. Now, looking at this, which is the element with maximum electron affinity? Which means the metals should have electron affinity or the non-metals? It is definitely the non-metals which will have more electron affinity. The non-metals have 4, 5, 6, 7 electrons in their last shell. So their ability to attract electron is much more. As we see that the size decreases, nuclear charge increases, and so the electron affinity increases. So at the last, means last but one, not the last but one. Last, neons have complete, this halogens, the inert gases have complete shells, so they have no electron affinity. There's no need to attract more electron. But these halogens, they have only one electron to draw in order to get the noble gas configuration. So what happens? Maximum electron affinity is shown by this group. With this, as we move, the halogens will show the maximum electron affinity. And we have taken the second period over here, which is the halogen in the second period, fluorine. Fluorine. So electron affinity, you can see that the electron affinity is increasing. Electron affinity should be fluorine, but there is a flaw over here. Fluorine and oxygen. Oxygen belongs to the 16th group, group 16, and fluorine belongs to the group 17. Oxygen in group 16 and fluorine, this is group 16, and group 17 is fluorine. Although they should have the maximum electron affinity, here there is an exception. Oxygen, instead of oxygen, it is sulfur, the next element which has maximum electron affinity. And instead of fluorine, the next element, that is chlorine, has the most electron affinity. That's an exception. Why it happens is, the size of the atom is very small. The size is very small, and this has 7 electrons, such a small radius, and it has 7 electrons. So inter-electronic repulsion takes place. The size of the atom is very small, and inter-electronic repulsion takes place, and as a result, the approaching electron does not feel the pull of the nucleus. So as a result, what happens? Here the exception is that sulfur is has more electron affinity than oxygen, and chlorine has more electron affinity than fluorine. And of course, the first group, that is group 1, the strongly metallic elements in group 1 has the least electron affinity. They would like to shed off their electron, not accept one electron. Electron affinity is the tendency of attracting electron. The next periodic property is electronegativity.